I suppose we can go ahead and get started then. First of all, welcome for the second session of the Industrial Internet of Things workshop. Those of you who are new, I'm Andrew Burns. I'm the presenter and UNI professor for the project. And then we also have, I'm presenting, but all of this work has really been spearheaded by Jacob Odell, the IoT engineer, and Nathaniel Bryant, the project manager at the Foundry 4.0 here at the University of Northern Iowa. So definitely, they're the ones responsible for this. I'm just the one that's presenting it for you today. So we have kind of what we're going to do today is last week we got started with our Raspberry Pis. This week we're going to actually set up a sensor on the Pi and then use the MQTT protocol. And then that's going to fit us into next week using Node-RED and then finally expanding it with microcontrollers. So today we're going to focus on setting up a sensor and the MQTT protocol. Today's goal, after today's workshop, you should be able to connect a sensor to your Pi. It'll publish and subscribe sensor readings using MQTT and Node-RED. We're going to learn what those things mean. So if it doesn't sound familiar to you right now, that's okay. We're going to talk about what each of those things means throughout the talk. If you do have any questions, number one, you're free to ask during the presentation. I ask that you just post them in the chat. I'll be monitoring the chat, and so if you have a question, you can post it there, and I'll see it. Respond as quick as possible. If you'd rather not ask the question now, or you come up with something later, by all means, feel free to email me, andrew.burns@uni.edu. I'm more than happy to go ahead and answer your questions, get you set up. In particular, I want to make sure that those of us that are, that plan to go to session 3 are completely done with the steps for session 2. And so anything that's preventing you from getting it done, and you want to, feel free to shoot me an email. I'm more than happy to help. So today, that's going to be our goal, is going to be set of sensors up and use some MQTT stuff. So yeah, first we're going to set up our sensor with Python code. The one sensor that we're going to use this time is the ADXL345. It's an accelerometer. It was, I think, around $18, and it has a quick connector, the QWIC connection on it, which allows us to easily plug it in and then connect it to our Pi Zeros without having to do any soldering. So here's the spec sheet for it. If you want to go ahead and read through it, it talks about the various pinouts, the assembly and wiring, how do you program it and calibrate it, things like that. We're not going to worry about it so much today. We're going to read values from it, but we're just going to read those values to then pass them on. So this is what your sensor is going to be looking like. Here are the quick connectors on the left and the right-hand side. I have connected mine on the left-hand side, although I don't think it matters. I think you could hook it up on the right-hand side as well. We'll just go ahead and use the left-hand side. If you're using this for other projects, I will mention that they do have a 3.3 volt regulator on here, meaning you can run it from either 5 volt or a 3.3 volt source, which is, depending on what kind of instrumentation you have at your lab, you might need that 5 volt ability. So that's the sensor that we're going to be dealing with. Physically, we'll go ahead and hook it up by connecting the quick connector onto the left side. This picture is of a similar board, but a different board, but it's going to look the same as far as the connection goes. Looking down from, quote unquote, the top, where the screen printing is on the left-hand side, you'll see the plug-in with the black wire that'll be on top. That connector only goes in one way. So if you attempt to insert it and it's going in hard, then flip it over and put it in the other way. And that'll make sure that you get the parts connected correctly. The nice thing about that quick connection is that it's going to give us an easy way to then just plug in the other ends of those wires into our Raspberry Pi Zero, and then it can read from it automatically. In particular, we have the following pinout. So on the right-hand side is what your setup is going to look like. You're going to have the quick connectors that are going to go ahead and map themselves into the Raspberry Pi Zero. The Pi Zero WH, W standing for, it comes with Wi-Fi, H meaning it comes with the headers on it as well. How do we want to hook it up? Well, we want the black wire to be connected to ground, which is pin 6. If I'm looking at my Raspberry Pi with the SD card at the top, the numbering goes upper left-hand corner is 1, and then to the right is 2, and then next row 3, 4, 5, 6. So I'm going to connect pin 6 to the ground. I'm going to connect the ground, the black wire, to pin 6. I'm going to connect the red wire or the power wire to the 5-volt pin 4. Note, you could also put it into the 3.3 volt pin 1. Either one is acceptable here. I chose to use it at the 5-volt because it makes it a nice clump instead of having it spread out. They're all kind of around those 4 pins. Then we're going to have a data line and a clock line to read information from that sensor. The data line is going to be blue on the quick connect, and you're going to hook that up to pin 3, which you'll notice it says SDA I2C. That's the data line on the I2C bus, which we're using. And then finally, the yellow wire will be the clock wire, which will go to pin 5. And so it'll look, something very much like this. If you look on the left-hand side, it'll be these 4 pins in that group that'll be connected. So we've got the power and ground to complete the circuit, and then we've got the data and the clock to go ahead and be able to actually read that data from it. It's using something called I2C, Inter-Integrated Circuit Communications, I believe. We enabled that at last week's session using RASB config. And so that should be something that is already working on your board. If you make these connections, an easy way to verify that that's actually, does my chat window block the slides? I don't know how the meeting is set up. I'm going to assume no. But if you can't read it, let me know. What we'll do is we'll go ahead and connect to our Raspberry Pi, and we'll run the I2C detect. So every device in an I2C system has a particular address. The address of our board, of our ADXL 345, is 0x53. That is 53 in hexadecimal. So what I'll do is I'm going to go ahead and connect to my Pi using the IP address that I found from the previous session. It's going to prompt me for my password. I'll type it in. It doesn't show anything, but it is reading my password. And then I'm logged in, and you can tell it should say now something like Pi at Raspberry Pi, telling me that I'm inside of that box. So I'm going to run I2C detect. The -Y just means, yes, I want you to run the program, don't prompt me. And then 1 means I want you to use the first I2C bus that's on there, which is the one that we've got it connected to. I run that, and you'll notice that it pops up with this 53 down here. That's telling me that there is a device with address 53 connected correctly to my Pi. So if you get to that point where I2C detect -Y1 says 53, it means that you've connected your 4 wires together and are ready to go as far as reading data and doing the rest of it. I'll pause for a brief moment and ask if anybody has any questions about getting your board connected correctly, so that it shows up on I2C. If you do have any questions, let me know. Okay, so we've got our I2C connected, device connected. So let's go ahead and actually write a program that's going to read in the values from that accelerometer. What we're going to need to do is install the Python library, Adafruit's ADXL34X library. And so to do that, I'm going to run the command on my Raspberry Pi. I'm going to run sudo pip3 install Adafruit-circuit Python -ADXL34X case sensitive. So case does matter in that case, or in this case. And then I'm going to go ahead and press enter. So like we reviewed on last session, sudo is just meaning run this command as a different user, and in particular, run this command as root. And so I'm installing the Circuit Python libraries for every user in the system. You wouldn't have to use sudo if you only wanted to install for your own or install in a virtual environment. That's just beyond the scope of this session. So it's going to take a little bit. The Raspberry Pi Zero is not, is far from the powerful desktops and laptops that we have now. So it does take it a little bit to download, not necessarily the network speeds, but the actual the processing that's having to happen. But if anybody has any questions during these brief breaks, that's a great time to let me know if you have any. We have a couple of those. There is one thing that will take quite a while to install, but we'll actually jump ahead, start that process early to streamline so we can go ahead and keep moving with it. So this is installing a bunch of libraries. I mean, a bunch relative, it's installing maybe 5 or 6 libraries that we're going to use to connect to our accelerometer. I believe, yep. So if it's successful, you'll see something down at the bottom where it'll say successfully installed. And you'll notice one of the things on that list is the Adafruit CircuitPython ADXL34X, and then some sort of a version number on there. So that's the final goal that we're getting to. If you get a failure or a red message or something, feel free, again, post in the chat, send me an email. We'll work through whatever issue you're having and make sure that gets set up. So what that has done is now set up the Python libraries so that we can, with very little code, read from the accelerometer. So normally communicating with the devices, like we're using the I2C protocol, you have to read in data from different registers and then interpret what that data means. By using the Python library, we don't have to worry about any of that. We just have to say, hey, give me the acceleration on the X, Y, and Z axes, and it'll go ahead and show me. Or this is beyond the scope of this discussion, but one of the things that we can also do with it is do stuff like, I want you to detect a tap. And so tell me when there's a tap happening. Tell me when the object is in free fall. Tell me when the object is being shaken, things like that. So you can do that with the Python libraries that are in there. So it kind of abstracts that away for us, which is going to make it easier for us to measure what it is that we're interested in measuring. Okay. So that's going to go ahead and install. And then what we're going to do is do some basic programming with it. I have a bit.ly link here, excuse me, bit.ly/day2-file1. That's going to take us to bit.ly day2-file1. It's going to take us to the simple test program in GitHub from Adafruit. So what I want us to do is go ahead and highlight everything that's on there, copy it to your clipboard, and then inside of your Pi, you'll notice that this one says it worked out okay. I'm going to list the contents of the directory ls. I see that there's a folder called documents. So I'm going to change directory into that documents folder, capital D, case sensitive. From there, I'm going to create a file called excel.py. You'll notice the touch excel.py does that creating of it. There it is. And then I'm going to open it with the text editor Nano. And then I'm going to paste from my clipboard. It's telling me that this is on my operating system, that, hey, it looks like there's some code here. It could be malicious. It's not in our case. So I'm going to paste that code in there verbatim. And it's going to, very simple code here. I'm going to Control O and then enter to write the file, to output the file. And then we're going to make one change to it. Basically, what this code is doing is connecting to the I2C board from the accelerometer, and then reading in the X, Y, and Z values and printing them, and then sleeping 0.2 seconds for it. So the one change I want to see us make is, you'll notice here in the comments, which they start with the octothorpe or the hashtag, it says for ADXL343, and then that's the command, that's the line that's uncommented. I want to comment that, so add an octothorpe or hashtag in front of it, and then I'm going to go down 2 lines, and on the line that says for ADXL345, I want to uncomment that or remove the octothorpe that's in front of it. And that's actually going to set up the driver to use the ADXL 345 instead of the 343. Again, we have the 345. It turns out you actually wouldn't notice a difference on the code that we're using because they operate like they're very similar boards. And the features that differentiate them are beyond just looking at the different acceleration. So and that code would actually work even if you didn't make this change. But for completeness, we're going to go ahead and do that so that we know we have the right accelerometer. So I'm going to Control O, which is going to tell me, hey, do you want to write to this file? I'm going to press Enter to do so. And then I'm going to press Control X and exit out of there. Okay. Now I've got my file excel.py. I'm going to go ahead and run it. Python 3 excel.py. And every 0.2 of a second, it's now taking a reading from the accelerometer. I've actually got this set up on the floor right now. So pardon me, I'm going to go flip it upside down. And you'll notice the values kind of switched there. And then it popped back to where it was. So it detected, notice the Z coordinates went from 7, 8-ish to -10 because I turned it upside down. The other values also changed from it. Okay. So that's a good sign. Our sensor is working like we expect. It's reading in the correct values. It's giving us sensible outputs. I'm going to press Control C at the same time, which is going to interrupt my program and stop it from executing, so I can go back and keep moving on with our presentation or with our build here. Cool. Questions, comments, concerns? So the slides contain static images of what we're doing live here. I will send out the slides after the talk, and so you can use those to follow along. I'll try to do most of it though through the live interaction so that you can keep up. I don't speed through something that takes a while to install. It keeps me honest in that regard. But does anybody have any questions that you'd like to ask about getting to this point where your accelerometer is displaying meaningful data? Okay. We're making good time. We'll keep on moving. So what we're going to do now is we've got the sensor, the accelerometer that's giving us values to our program. But right now we can't do anything with those values other than print them to the screen. And obviously, like we're not out here to print something to the screen. We want to instrument our foundries, instrument our systems, take those measurements, feed them into some other program or visualization or script that is going to take action based upon those values. So what we need to do is take those values and share them with other entities. And that's what MQTT is. It's actually a lightweight protocol, usually used for Internet of Things devices. That's a publish-subscribe publish-subscribe protocol where certain clients can have interesting information that they want to share. So they would publish that information along with a tag to identify, say, the category of that information. And then other clients can subscribe to certain topics or subscribe to that tag. And then whenever somebody publishes that information with that tag, the subscribers automatically are informed of it. So what we need 3 different pieces here. We need an MQTT broker that's going to be given the information and share it. So the broker is going to manage, hey, if you want to publish something, you send it to the broker. If you want to subscribe to something, you let the broker know. And so that's what we're going to set up first. And then we're going to set up clients both to publish data and to subscribe to data. and then we'll see how we can go ahead and interact or connect those two in there. Before we get too far, I'd like us to start installing Node-RED, because this actually does take quite some time. If you go into, I apologize, they're out of order here, bit.ly day2-file3. I've got a command in here. You can copy this command. I'm going to paste it into my Raspberry Pi. I'm going to press enter. It's going to say, are you sure you want to do this? I'll say why. And it says, do you want to install the Pi specific nodes? I'll say why. And then it's going to go ahead and start a big long process. So I'm going to let this run. Notice it says 20, 30 minutes. So while that's running, I'm going to connect to my Pi again on a new SSH session, so that we can continue on with the broker stuff. So Node-RED is what we're going to use to subscribe to the information. It also gives us, like a beautiful interface. Our session next week will be over using Node-RED in detail. This time we're just going to use it just a little bit, just to subscribe and see that data is on there. So yeah, we've got Node-RED installing. So let's jump back to setting up a MQTT broker here. Okay, so what we're going to do is run sudo apt update inside of our Pi. What that's going to do is update the list of available packages so that I can be sure when I do an install, it's going to be the most recent version for this particular operating system. Once that's done, I'm going to go ahead and run sudo apt install mosquito with 2 T's, MOSQUITTO. And what that's going to do is install the Mosquito MQTT broker for us to use. And again, the MQTT broker is the person or the entity that's in charge of saying, hey, if you want to publish something, you give it to me. And if you want to be told when things change, aka if you want to subscribe to something, you tell me that you're subscribing to that topic or that category, and then I'll keep you in the loop on it. We're going to run the broker on the Raspberry Pi, although you could run the broker on a separate server, and a lot of examples that you'll see online will sometimes have brokers that are separate from the Node-RED ones. In our case, for ease of use, we're just going to put them together. So sudo apt install mosquito. I'm going to press enter. It's going to go ahead and prompt me, do you want to continue? I'm going to say yes. And then I'm going to let that work for a while, installing mosquito. While we wait for that to install, does anybody have any questions about what MQTT is, how it fits into our overall picture here? It's like the critical glue that's going to be needed, that allows us to share information from our various devices and then use them to make nice visualizations and conditional actions and things like that, stuff that we'll see again next week during our talk. So what we're going to do after Mosquito installs is we're going to set a password for the broker. Basically, initially, there is no username and password for the broker, meaning if I want to publish some information, all I have to do is say, hey, Mosquito, publish to the category birthday, April 26th, and give it that information. And it doesn't care who I am. It may have never seen me before. I can be from outside the network, whatever. Mosquito will go ahead and say, hey, you're trying to publish X, then I will go ahead and see who's subscribed to X and share that information with them. What we probably want to do is limit access to our broker and say you can only use the broker if you know the username and password, or you know a username and password. And so what this command is going to do, sudo mosquito password -c, is going to create a password file at etc mosquito password for the user node red. And then I'm going to use the password pass1234. And you're welcome to use that as well. But if you would prefer, you can use something different. Just keep in mind that in the future slides, when I'm referring to pass1234 or user node red, that you might want to use something different, whatever it is that you put in there. You can actually add more users to this, so it's actually not the end of the world if you forget it. It's very easy to reset, and it's also very easy to add more users to get that to work. Looks like we've got a question. When I simply use the broker, does that affect the people publishing the broker, transcribing the broker? Both, actually. So if you want to publish, you have to know the password. And if you want to subscribe, you have to know the password. Otherwise, it'll just say access denied, and then it won't let you get to it. So yeah, it's kind of a dual-ended thing. In our example, for ease of use, we're going to use just one username and password, but you can, and the intent is usually every device has its own username and password. It's not a requirement that that's the case though, but yeah. Does that answer your question? Cool. Okay, so we'll run sudo mosquito password -c etc mosquito password node red password PASS1234 PASS1234. And now if I take a look at my mosquito, there's basically a hashed, or if you will, like a weak encrypted version of the password that's being saved here, so that I can communicate with it that way. We're going to make a couple changes to the configuration file. We're going to go ahead and open up sudo nano etc mosquito mosquito.conf. I'm going to, at the top, write per listener settings true. And then I'm going to go ahead and go down to the bottom. It wouldn't matter where you put this, but stylistically, we'll stick it at the bottom. I'm going to say allow anonymous false. That's going to make sure that everybody has to authenticate. I'm going to say listener 1883. It's basically telling it the port or where I want it to listen to. And then I'm going to tell it that the password file is the etc mosquito password file that I created earlier. Make those the 4 changes there. Control O, enter to save, and then Control X, and I've gotten out of it. Last thing I want to do is go ahead and restart Mosquito so that it can use the settings that I've set up. Sudo service Mosquito. Oops, I guess we're using something different. Sudo system control restart Mosquito that service. That's going to take just a brief moment. Now, what I'm going to do, and this is a good habit to get into, I've restarted the service. So this is by service, I just mean it's running all the time. I've restarted it after making some configuration changes. If I configured it wrong, it will not start, and so it will not be running. So what I'm going to do is I'm going to ask the system to give me the status of Mosquito. And I can see here, it tells me that it's active, it's currently running. That's good news. It means that the changes that I made to the configuration file are valid. that we now have a broker set up and ready to go. And then you can hit Q and you'll exit out of that. Any questions on setting up the broker? Okay. Next thing we're going to do is set up the client, one of them. So we're going to have two clients. One is going to be a publisher, one is going to be a subscriber. The publisher is the one who's obviously sharing data. And that's what we want to do, is we want to take our accelerometer readings and publish them to our broker. And then we'll use Node-RED to subscribe to those values and read from them. What we're going to do is we're going to install a Python library called Paho MQTT. Sudo pip3 install MQTT. And then it's going to take a little bit while it runs through that process. And so we're going to keep moving while this is running in the background for us. Simple as that. Now I have the Python library that will let me publish it and subscribe, aka be a client for an MQTT broker. So what we're going to do is use a program that we modified from earlier. So you can go to bit.ly/day2-file2. That'll be the last one, I promise. And what that's going to contain is the code, the Python program, the Python script to go ahead and do the publishing of the data. You'll notice some of this looks familiar. So there's my Adafruit driver. There I am creating it. Here I am reading the acceleration values and publishing them to the current tag or current category. And then some of these are new. So on message and on connect. Again, we're just gonna we'll dive into those at a later date. For now, we're just going to go ahead and take them as they stand. But basically what it's doing is sets the username and passwords, connects to the broker, and then publishes data with the tag or category or label of current with a capital C, case is sensitive in this case. I will point out two changes you'll have to, or two lines you'll have to change. Notice I didn't want to leave this file out there with the username and password in there, even though this isn't, this should not be public facing. Your setup, these are just kind of an experiment for us, like an experimental setup. I still didn't want to put the username and password in the file that was available. So what you'll have to do is you can copy all of the text. You can then go to nano /documents with a capital D, publish _ excel.py, or you can name it something else if you want. Paste those values in there, and then come up to the username and password and actually fill those in. So in our case, it was Node-RED pass1234. Again, if you set it up to be something different, you'll just put that in there. Other than that, the file is ready to go. So I'm going to Control O and then hit Enter. I'm going to Control X. Yeah, and then I'm going to go ahead and run it. So I'm going to CD into the documents directory. I'm going to Python 3 publish excel.py. And again, this is going to be reading from my accelerometer and then publishing them to the MQTT broker that I set up, Mosquito. If it doesn't work, it's going to give me an error. You'll notice that it goes ahead and displays it every 2 seconds. That's a good sign. What that means is that the client was able to connect and is now publishing that data every 2 seconds, just like we would expect. we can really quickly, suppose I do the password wrong. No, that shows what I know there. Earlier I was getting a TLS error when I did that. I'll have to check on why exactly. Has 1, 3, 4, 5, 3, 4. Cool. At this point, we've got the Raspberry Pi connected to our Wi-Fi. That was session 1. We've got the accelerometer connected to our Pi. We did that first. We've got the broker that's running and managing the publishing and the subscribing. That's the Mosquito service that we installed. And then we have the MQTT client, which is publishing the accelerometer values. That was the code that we just pasted in. Does anybody have any questions on the recap of all of the pieces that we've made so far? I know it's a lot, but if you have any, like you can ask questions now, or you can send me an email and ask questions later. Cool. Now we'll get into, so we're publishing this data, but nobody's subscribed to it yet. What we're going to use to subscribe is Node-RED, and we were in the middle of setting that up. We've done this step already. I'm going to go ahead and go back to it. Notice it got done with all of those things, and then it's paused, and it's telling me what is the settings file to use. We'll go through the slides. Most of these, you just say enter. So it says settings file. I'm just going to hit enter and use the default. Do I want to set up user security? I'm going to say no. Do I want to enable the projects feature? I'm going to say no. Enter a name for your flows. I'm just going to hit enter. Provide a passphrase to encrypt your credentials file. Again, pick one for yourself. As far as themes go, I'm going to select default, and then default, and then allow Node to load external modules. I'm going to say yes. Okay. So basically, I went through and did default, like the default. With one exception, I turned user security off. Other than that, everything was default. So that's how we install Node-RED on the Pi. And then what I'm going to do is connect to it, and then use it to, tell it, hey, I want you to subscribe to this information that's being published constantly. And so we can come back to it. What I'm going to do is just run node-red-start. I'm going to hit enter, and then it's going to take it a little bit. You'll notice it's giving me a URL here that I can click on. I'm going to go there, but you'll notice it says unable to connect. Again, the Pi Zero is not the speediest device in the world, but it's low power and it's cheap. It's what we want for an IoT system. And so I'm going to wait a little bit until Node-RED says that it has launched the browser, or sorry, that has launched the server and set up for it. Server now running, started flows. I refresh the page. Boom, now I have a Node-RED set up. Yeah, I'm connected and ready to go. I will mention, again, next week we will dive deep into Node-RED. Right now, there's a lot of pieces that are on the screen. We're going to look at just enough to get a subscriber, view the output, and then we'll be able to say, hey, we successfully configured all of these things. We've got a broker, we've got a publisher, we've got a subscriber, and we've got an ability to view that through a meaningful interface Node-RED. What I'm going to do on the left-hand side is I'm going to scroll down to network, and I'm going to select MQTT in. and I'm going to drag it over and just drop it here into the screen. I'm going to double click on it, and then it's going to let me add a new broker. I'm going to click the plus, and I'm going to say the server is localhost. I'm going to go to security. The username we said was node red, and the password was pass1234. And then I'm going to go ahead and click add/done. And now my server, no LastPass. I do not want you to save that. Then it's ready to go. Now I'm going to topic. I'm going to put, we said current with a capital C, and then I'm going to say done. And now what I've done is I've made this block listen for or subscribe to the current MQTT messages. Now what I'm going to do with that, well, let's go ahead and display that in the debug window. So I'll drag the debug node over here. I'll just drag a line between those two. Now they're connected. And that's going to allow me to actually view the raw data that's coming from the current tag. I'm going to press deploy. It tells me it was successful. It tells me it's connected to the broker, which is great news. Up here, I'm going to click on the little bug symbol to take me to the debug menu. Now, nothing's showing because we're not running our publisher yet. So I'm going to go back to my publisher program, the publish excel.py. I'm going to start it. And now I'll look on the right-hand side and notice every time it prints to the screen, it's also sending that message to the debug node. So it's publishing to the broker like we would expect. And the subscriber is actually catching it like we would expect to. Right now, the values are just strings with the X, Y, and Z axes. We'll see next week that we'll actually use, you can have strings, you can have integers, you can have floats. The nice thing about having the ability to make it numbers or things like that is you can do calculations with them and graph them and actually have meaningful decisions being made without just having to look at debug information. I am going to stop the publisher. I can then clear it, delete all messages, and then I notice that they stopped because, again, there's nothing being published. But again, as soon as I start it, publish, and then one of them comes over right off the bat and gets displayed. Okay, so what I've done here, again, the slides contain the information that you'll need to do this setup, but we've already talked that through. Yeah. So what have we achieved today? We installed the ADXL 345 on our Pi, and got it to read in values. So we flipped it upside down and we saw the values saw the values changing. The accelerometer, obviously, I think you can think of scenarios when you might want to instrument something with an accelerometer, like maybe the tilting or flipping upside down or shaking or tapping you're trying to detect. The key thing is that device communicates using I2C, which is a standard protocol for communicating between usually these small, low power embedded systems or microcontrollers. And so there are plenty of other sensors that use I2C protocol. The process for setting them up would be very similar. You'd still connect them to the same pins on the Pi. You would still have a device driver if necessary. And then you could go ahead and do whatever you needed to do with that data. So temperature, humidity, light, infrared values, things like that, whatever you're reading from it. We set up Mosquito for our MQTT broker. That was a short couple of, run a command to save it, and then update the configuration files. We created a publisher. In particular, we copied some code and made it be the publisher, which took the values from the MQTT client and shared them with anybody who was listening, aka any subscriber to the current. And then we also set up Node-RED to be a subscriber to our with our MQTT broker, and viewed the published data. By itself, this flow isn't very, it's pretty simple flow. But in reality, like in actual deployments, when you start building it together, you can get some pretty complicated Node-RED flows, with multiple sensors or multiple values being read in. If we take a look at the kinds of things that it can do, and again, you had this on Startle on yours, so feel free to scroll through and kind of see some of the stuff that it can do. You can put various functions in there, delays, triggers, where do you want to get your values, various types, MQTT, but HTTP is also there, WebSockets are also there, serial. You can get it to play a sound when certain conditions are met or things happen, parse through different files, save the files, and then something that we're going to get to is the ability to actually then say graph it and create a dashboard that shows you all of the different pieces, and lets you make the, basically make the decisions that you're trying to make using your industrial Internet of Things devices that you've augmented your system with. Right now, most of our, we did a decent amount of Unix and Linux commands to connect them together. Most of that is now going to be over, at least for the next session, the next week, because we're going to play around with Node-RED a little bit more and build something a little bit more interesting with it. And then on the last day of our session, we will go ahead and expand the microcontrollers. So I just mentioned again, if you have any questions, certainly you can consult the slides, you can look online. Do not hesitate if you want to send me an email, andrew.burns@uni.edu. I'm more than happy to help. It's what I'm here for, literally. So if you have any questions trying to get this set up, feel free to go ahead and reach out to me. And again, where we're trying to be is I'd like you to be completely set up with the things that we did. If you look at the achievements, you're caught up with all of those, so that next week, Wednesday, we can dive in with some interesting Node-RED. So otherwise, any final questions or last minute thoughts that you want to share? Awesome. Well, thank you everybody for coming, and I look forward to continuing on next week. Thank you.